Hello, everybody. Today we are combining like terms. So, a group of like terms together and determine how many of each there are. So, right in the beginning here, we have a bunch of different items. For example, we have popcorns and movie boards, and we have how many popcorns. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many movie boards do we have? We have 1, 2, 3, 4. So we have 14 total popcorn and four total movie boards. Of course, you would never say I have a popcorn and a popcorn and a movie board and a popcorn and a movie board and a popcorn. You would never do that. You would just say I have 14 popcorns and I have 14 and 4 movie boards. So when we're combining like terms, we have algebraic terms that can be combined in a similar manner. A term can be considered like if it has the same variable with the same exponent. If the exponents are different, then they are not like. And constants are also numbers that can be combined with each other. So down here is a good example. We're going to use a different shape, or I used a different color to group like terms together and then explain why. So I highlighted in yellow all the terms that have the variable x. So we have our coefficients that are all different, 11, 7, 4, and 5. And our variables that are attached to the coefficient are x. So each terms are highlighted in yellow are like. They are the same. Now, the ones in green are all called constants. And just recognize that those are numbers. Another way to say numbers in math are to call them constants. So those are synonyms. So all of our green ones here are constants. Now, our blue ones are different from our yellow ones in the fact that they have a different variable. So here is y and here is x, which does not make them similar. These are not like terms. So I have 13y, 9y, 12y, and 15y, which all can be combined. Now, the unique one here has a coefficient of 3 and a variable x raised to the second power. So we have an exponent. So this one's completely different because it has a variable with an exponent. So when I want to combine these, all I have to do, for example, for the x's, now we only have 3x squared, so it stays the same. There's only one of those, so I rewrite it just as it is. But if I want to combine my x's, I have to add up how many there are. So all I do is add up the coefficients. So how many x's are there? Well, I had 11 here, so I have 11 plus 7 plus 4 plus 5. Now I have 27 x's. Now how many y's do I have? I have 13 plus 9 plus 12 plus 15. So I have 49 y's. Now I want to add up my constants. So I have 1 plus 24 plus 15 plus 3 plus 8. All right, so we are combined now. Everything has been combined. So for number 1, I'm going to give you another example. So I highlighted the ones that are like terms, just like in the top. And the ones in blue here are just different. They have different variables. So 3y is different than the other two because y is a unique variable. It is not the same as x. So if I want to combine the ones that are alike, because they have the same variable with no exponent, of course, I can just take the coefficients. So for this one, it's 6 plus 12. And I'm going to have 18. So remember, your variables are the same. So you have 18 x's. There's nothing to be combined with 3y, so it just stays the same. There are no other y's in this problem. It's going to be positive 3y or 18x plus 3y. All right, so let's take a look at number 1 on your first page. So, for example, here
On Algebra Touch, if you wanted to combine these terms, I can combine 6x with 12y just by tapping the plus button. Now I have combined those two. 6x plus 12x gives me 18x, and then I have 3y. So if you wanted to try to combine these, if I tap the plus button, it won't let me. Why? Because I have different variables. How about that?
For number 2, we have constants of 5 and 9, each one are positive, and I have a term with y as a coefficient with 11, so it's 11 times y, whatever y is. So I can add up my green ones, which are constants, also called numbers, with 5 plus 9, and I get 14, it's positive, and then I have 11y, it's the only one there, so I keep it the same. So now I have 11y plus 14. So this is basically addition. Now number 3 is even easier because I only have 6x's and I only have 2 y's. There's no combining. There are no more other x's and there are no more other y's. So I can keep it the same as it is. It's in the simplest form. So if I wanted to simplify number 4, because I do have different terms here, I have a term of 15x and a term of positive 9x, right? But it's different from our constant, right? Because our constant, although a constant is a term, it has no variable, so I can't combine it. It is no x. It is just a number. It is not attached to a variable. So these are unique in the fact that these terms have a variable attached to a coefficient as part of the expression. So if I want to add up or combine my x's, I can just take 15 plus 9, and I'm going to get 24 x's, and then positive 19. I can rewrite my expression in the simplest form there.
All right, if you want to take a look at number 4 from the first page. For number 4, we have 15x plus 19 plus 9x. So a strategy to use instead of highlighting these could be to rewrite the problem with the like terms next to each other. So, for example, if I wanted to have like terms next to each other, I would be rewriting it or moving it one next to the other so that I can combine them. So we got 15x plus 9x plus 19. Now, I can combine my like terms, and again, if I tap my plus sign to combine them, I have a constant of 19 trying to combine with the term of 24x, and I can't combine them because 19 has no variable. It won't even let me on Algebra Touch.
For number 5, they are all the same. Each one of these are y's. So how many y's are there? I have 10 plus 6 plus 8, and I now have 24 y's. So you can rewrite it as 24y.
Take a look at number 5. We have 10y plus 6y plus 8y. So we have the same variable attached to some different coefficients, but because the variables are the same, I can combine each one. And I'm going to end up getting 14y when they are all combined.
Now on this one, it's a little unique. Sorry about the extra highlight. It's hard to get rid of once it's there. It just gets darker. So we have 8x squared, which is unlike 10x. All right, so the reason why these are unlike terms is because this has an exponent and this doesn't. And I think it's important to notice that if you did have a different exponent there, for example, this we could combine because the exponents are the same. However, now that the exponents are different, they would be unlike terms. Even though there's an x there, because the exponents are different, you can't combine them. So when we're subtracting like terms, right, like terms can be subtracted, but remember, keep the sign as a part of the term. So when they say keep the sign, what they mean is that, for example, 14x plus 3y plus is really the sign. This is a positive 3y, and this is a negative 8x. So we're going to use the rules for integer operations as you combine terms. So, for example, we have 6c take away 5c, but this is a negative 5. So if you owed me $5, but you had $6, you would have $1 left. Right? So when I combine these two terms, I only have 1c left. And then we have 13c take away 5c. So if I combine 13 and negative 5, or take 13, right? Take away 5, I have 8c's left. So for number 7, we have 11a, and you could say minus 5c plus 3a. But for when we're combining like terms, we want to use the sign. When they say keep the sign, they're talking about whether it's positive or negative, because it's going to be part of the term. So the sign tells us whether the term is positive or negative. So here's a good example of that. Okay, so we have 11a, negative 5c, and we have a positive 3a. So we can combine our 11a and our positive 3a because they have the same variable. And when I combine those, all I have to do is really add the coefficients together. So if I have 11a's plus 3a's, then I have 14a's. Now negative 5c has nothing else to be combined with. There are no other c's in the problem, so it just stays the same at negative 5c. And then when you read it as an expression, you can read it as it is. You can say 14a minus 5c. But I like to use negative, so it would be 14a combined with negative 5c. It's another way to read it.
So for number 7, we have 11a plus negative 5c. Remember, because like that plus sign means that I'm combining it here on Algebra Touch, and then combining with a positive 3a. So again, the strategy would be to move terms that are alike next to each other. So if I wanted to take my variables, I can move them next to each other, and I could rearrange these any which way. And this is one of my favorite ways. It makes it a little less confusing when you rewrite it, right? So now you can just see it's a negative 5c. And I can't combine those. Why? Because my variables are different. But I can combine my a's because I have 11 and 3 of them, so I can combine them. Okay? So then I have negative 5c plus 14a, or it can be said as 14a take away 5c, or 14a minus 5c, or 14a combined with negative 5c.
So for number 11, we have 6t plus 19s, negative 10s, negative 2t. Or as some people would read it, 6t plus 19x plus 10s minus 2t's. Right? So when they say keep the sign in the front, it's because we have 19 s's, but you're going to take away, you're going to have negative 10x's, 10 s's in the next one. So let's just start with our t's. So we have 6 take away 2, and you're going to get 4. But because you could also do it the other way, if you had negative 2t's, you can have combined with 6t's, and you're still going to get 4. So either way that you do it, you're still going to be fine, as long as you're combining right. And then for the other blue highlights here, they have different variables. It's different than t. They are s's. So I have 19 s's and negative 10 s's. So you can just do 19 take away 10, which is fine. You're still going to get 9. But if you wanted to do it the other way, you could take negative 10 and combine it with 19, and you're still going to get a positive 9.
Okay, so for number 11, they don't have the same variables in Algebra Touch, but I'm going to use these variables instead. So instead of t, I used n, and instead of s, I used b. So my variables are going to be the same for these, all right, on this program. So I do have my b's next to each other, all right, and it wouldn't matter which way they are, but I want to move my variables that are the same next to each other. So I can then combine them by tapping them. Again, I can't combine these because they have different variables. So for number 13, you got all these constants and then 12w. All right, so the term 12w is here, right? And you saw that I kept it the same. You might be wondering why there are no constants in it. They're very different than the other ones. Well, let's try to combine our constants. So we have a -4 being combined. And when I combine it, I'm just using the plus button. Plus 12. And then -8. And it gives me 0. So when you combine the constants, nothing ends up being there. So just to show you what a problem would look like, all right, for number 13 I would have 12, and they don't have a w, so I'm going to use y -4. See how it changed to +4? Because I'm combining it. So I'm sorry, see how it changed to +(-4)? It's because I'm combining them. So in between the cancel and the done sign, you can see what it looks like on your paper, but on Algebra Touch they're showing you the plus sign because that means combination, and it's really a -4. It's not -4, it's -4. And then I have +12, and then I have -8, right? And I'm combining a -8. So they use the plus signs as combinations. Alright, so again, I kind of want to move things around to be next to each other, but all my constants are right next to each other. So that's really cool. So I'm going to combine all my constants, -4 and +12, and then 8 and -8, and I get 0. So all I have left is 12y because we have +8 -8, and it's basically like that, but you never say +0. You wouldn't say plus nothing. You would just write it as it is. So now for number 15, we have for number 15 we have 4x squared plus 14x squared take away 1x. So these are very similar because they have the same exponent. If they had different exponents, we could not combine them. Okay? So because they have the same exponent, we can. So all I have to do is add my coefficients together. So I recognize that these are both x squared, so I can take 4 plus 14, combining those numbers, or those coefficients, whatever you call them, whatever you want to call them, right? And I have 18. So now I have 18x squared. Now there is only one term over here. This is -1x. All right, so it would be staying the same. And I just want to point out that this is the right answer. However, if my exponent was different, I could not combine these, right? If this 2 was a 3, I wouldn't be able to do it. It's completely different. If your exponents are different, you would never be able to combine them. All right, and also, you can look at this as -1x raised to the first, because any number raised to the first is actually itself, so this 1 is actually invisible. It wouldn't really be there. Alright, for the last one, I got number 16, so I got 15x plus 2.5, and this is an equilateral triangle, so that means that all sides are the same. So because they told me what one side is, I know what the rest of the sides are. So I have 15x plus 2.5 on each side. And when I want to combine them, I basically just have to add them up because all the sides are the same. So I have 15x, so I can just add 15 one right after another, and I'm going to get 45. But remember, repeated addition is also multiplication. So how many 15s do we have? I can have 15.
How many times do I have it? I have 3 times. So you're still going to get 45. And then I get 2.5, and again, you could add those together separately, which would take you way longer. And you'd end up getting 7.5, but the quicker way to do it would be to use multiplication. How many of them do I have? I have 3 of them. I get 7.5. So my new expression simplified is 45x plus 7.5. All right, that's it for today. Everybody have a great day and stay safe.